Dear students, hope all of you have gone through the video and did your assignments. So today we'll continue with the topic that we started in the previous class, that is number system. I have already explained few things about number system. So today in the beginning we'll start with few more examples. The first question is express 0.48 when 4 and 8 both are recurring decimals or repeating decimals. Express 0.48 in P upon Q for. So we have already done a few questions of this type. Let x is equal to 0.484848 and so on. Now as you can see, two digits are repeated here, so we have to shift this decimal two places towards right. For that we have to multiply the whole equation. Let it be the equation number 1. We have to multiply the whole equation by 100. So when we multiply equation 1 by 100, multiply equation 1 by 100, then we will have 100x is equal to 48.484848, so on. This is the second equation. Now from second equation you have to subtract the first equation. So below the second equation you simply write the first equation and now you have to subtract. Now you can see 100x minus x will give you 99x, and in both the numbers you can see the decimal part is the same. So we'll subtract the decimal part will be subtracted. 48 minus 0 will be 48. So x is equal to 48 upon 99. X is equal to 48 upon 99, and that is your answer. I hope it is clear to all of you. Now we will do one more example, and the question is represent root 61 on the number line. Represent root 61 on the number line. As I told you in the previous class that for representing these irrational numbers on the number line, we use Pythagoras theorem. So for first of all you have to tell me a number which is a perfect square number and which is close to 61. So you know 64 is a perfect square number because it is a square of 8 and it is closer to 61. So if you see, if I take a right angle triangle and say this side I have taken 8 and this side I have taken root 3, and now suppose this is x. So if you apply Pythagoras in that right angle triangle, all of you know root 3 square plus x square is equal to 8 square. That is the Pythagoras theorem. So if we apply Pythagoras, then 3 plus x square will be equal to 64. X square is 61 and you can see x is root 61. That means this length will be equal to root 61. Is it clear? Now I will tell you how to represent this value root 61 on the number line. First of all, you draw a number line like this. Okay, now first of all we have to find the value of root 3. To find the value of root 3, what we do, you draw a line perpendicular to the number line at point this 0. You draw a line perpendicular to the number line like this. Clear? Now in your compass, take a radius equal to 2 units, and then with this point, putting the needle of the compass at this point, you draw an arc like this, such that this is 2. Now you see, if this distance is 2 and this distance is 1, then easily you can understand that using Pythagoras, this length will become root 3. Is it clear? I repeat, keeping the pin of the compass at the mark 1 and with radius equal to 2 units, you have to draw an arc which cuts this line at a point, and the distance of that point from the origin will be equal to root 3. So in this way, we have found the value of root 3. Clear? Now, as I told you, the hypotenuse of the triangle should be 8. So, in your compass, you take a radius equal to 8 units, and keeping the needle of the compass here, you have to draw an arc, and that arc will cut the number line here. So, this distance is what? 8. And if this distance is 8 and this is root 3, so using Pythagoras that we have already used there, using Pythagoras you can see that this distance will become root 61, like this. Clear? Is it clear to everybody? Now, one more example, and it's a new type of question that we have not discussed in the previous class. So all of you pay attention. Represent root 3.5 on the number line. Represent root 3.5 on the number line. Now you can see we have done the representation of few irrational numbers, but they are all the numbers inside the square root, all whole numbers. But here it is a decimal number. Now how to plot, how to represent square root of 3.5 on the number line. So first of all, I will tell you the working rule, and then I will explain how we are doing it. First of all, you draw a line AB of length 3.5 centimeter. Now if there is under root 4.7, then you have to draw a line of length 4.7 centimeter. If it is under root 8.9, then you have to draw a line AB equal to 8.9 centimeter. Clear? Now, you have to extend this line AB to point C, and this length BC should be 1 centimeter. You have to extend line AB by 1 centimeter. Clear? Now, using your compass, you draw the perpendicular bisector of line AC and find the midpoint of line AC. Using the compass, you have to draw the perpendicular bisector of AC so that you get the midpoint of AC. Let it be point P, and with that point as center, you draw a semicircle. Taking P as a center, you have to draw a semicircle. Now, once you have drawn the semicircle, at point B, you have to draw a line perpendicular to AC. At point B, you have to draw a line perpendicular to AC and let that line curves the semicircle at point, say, Q. Then this BQ will be nothing but under root 3.5 centimeter. The length BQ will be equal to under root 3.5. Is it clear? So, I repeat, if you have to find the length or you have to plot, you have to represent square root of 3.5 on the number line. First, you draw a line AB of length 3.5 centimeter, and then you extend that line to point C such that the length BC is equal to 1 centimeter. Now, with your compass, draw the perpendicular bisector of the length AC such that you get the midpoint of AC, that is point P. With P as a center, you have to draw a semicircle. Once you get the semicircle, you have to draw a perpendicular at point B and let that perpendicular line cuts the semicircle at point Q. So BQ is the line which is, BQ is the length root 3.5 centimeter. Okay. Now let me explain how. Suppose you have to find the length square root, or you have to represent root x on the number line. So first of all, you draw a line AB of length x and then extend it to point C such that this is 1 centimeter. That means now AC is total x plus 1 centimeter. Now with the center P, midpoint of AC, you draw the semicircle and there is a perpendicular at point B and this is point P. Now pay attention, AC is x plus 1. So AP will be x plus 1 by 2, and that is nothing but the radius of the semicircle also. So if you join PQ, then PQ will also be x plus 1 by 2 because PQ is also the radius of the semicircle. AP is x plus 1 by 2, that is the radius of the semicircle, and PQ is also the radius of the semicircle, so it is also x plus 1 by 2. Is it clear? Now see, PC is x plus 1 by 2, that is the radius of the semicircle. Then PB will be x plus 1 by 2 minus 1 because this length is 1. So PC minus BC gives you PB. So PB is x plus 1 by 2 minus 1, that is equal to x plus 1 minus 2 by 2, x minus 1 by 2. Now, if you apply Pythagoras in triangle PBQ, excuse me, using Pythagoras theorem in triangle PBQ. So x minus 1 by 2 square plus BQ square is equal to x plus 1 by 2 square. Clear? And now I'll continue here. That is bq square is equal to x plus 1 square by 4 minus x minus 1 square by 4. Take 4 LCM. X square plus 1 plus 2x minus x square minus 1 plus 2x. X square cancelled, 1 cancelled. So it is 4x by 4, that is equal to x. So you can see that bq square is x, then bq will be equal to root x. So I have explained that if you start with AB as x, then the length BQ will be equal to root x. Is it clear to everybody? Now we will do one more example. And the example is simplify 8 upon root 5 plus root 3 plus 12 upon root 5 minus root 2. 8 upon root 5 plus root 3 plus 12 upon root 5 minus root 2. Now, what we do, as you can see, this denominator is an irrational number, because I told you any number with a square root sign will be irrational. So this is an irrational number. So we have to rationalize this denominator. For that, we have to multiply this irrational number by the rationalizing factor. Now to get the rationalizing factor, if there is a plus sign over here, you change the sign and you will get the rationalizing factor. Means 8 into root 5 minus root 3 upon root 5 plus root 3 into root 5 minus root 3. So we have multiplied both the numerator and the denominator by the rationalizing factor, which is root 5 minus root 3. Similarly, here also this root 5 minus root 2 is an irrational number, and here the rationalizing factor is root 5 plus root 2, because we have to change the sign, so it will be root 5 plus root 2. So you multiply both the numerator and denominator by the rationalizing factor, that is 12 into root 5 plus root 2 upon root 5 minus root 2 into root 5 plus root 2. Now we are going to apply an identity that you have already studied in class 8, and the identity is a plus b into a minus b is equal to a square minus b square. So in both the denominators we will apply this identity. So it will be 8 into root 5 minus root 3 upon root 5 square minus root 3 square, plus there it will be 12 into root 5 plus root 2 upon root 5 square minus root 2 square. Now 8 into root 5 minus root 3 upon, here it is a square minus b square, so it will be root 5 square is 5 and root 3 square is 3. Similarly here 12 into root 5 plus root 2, and this is again 5 minus 2. Now 8 into root 5 minus root 3 upon 5 minus 3 will be 2. 5 minus 3 is 2 plus 12 into root 5 plus root 2 upon 5 minus 2 is 3. So if you cancel this 8 by 2, you will get 4, and here 3 4s are 12, 4 again. When you open the bracket, it will be 4 root 5 minus 4 root 3 plus 4 root 5 plus 4 root 2. Now you see 4 root 5 plus 4 root 5 will be 8 root 5 minus 4 root 3 plus 4 root 2, and that will be your answer. Clear? Now there are few laws of exponents in case of real numbers. They are the same as you have already studied in lower classes, like laws of exponents. A to the power m into a to the power n is equal to a to the power m plus n. Then a to the power m divided by a to the power n is equal to a to the power m minus n. Third one, a to the power m whole to the power n is equal to a to the power mn, and anything to the power 0 gives you 1. Then square root of a, it means a to the power half. Similarly, cube root of a means a to the power 1 by 3. Similarly, fourth root of a is a to the power 1 by 4, and so on. Clear? These are few laws of exponents. I hope it is clear to all of you, and by with this we have finished our topic number system. So you have to go through the chapter carefully, and then you have to attempt all the questions given in the assignment and in the chapter as well. So now we are going to start a new topic which is called polynomials. Polynomials, you have already studied about algebraic expressions or their addition, subtraction, multiplication and all. So polynomials are nothing but algebraic expressions in which we have one or more terms and they are connected with either addition, subtraction or multiplication and so on. Now, suppose I write 4x. So as you know, this is an algebraic expression which has only one term. As it has only one term, so it is called a monomial. It is called a monomial. Then suppose I write 5x square plus 9. Now again we have an algebraic expression which has two terms, and as there are two terms, so we call it a binomial. So this is a binomial. Clear? Now suppose there are three terms. Here you can see there are three terms, and when there are three terms, then we call it a trinomial. And if it has 4, 5, 6 terms, we call it polynomial. Actually, they are also polynomial. Single term monomial, more than one term will be a polynomial. Now special names are given to these polynomials, binomial and trinomial. So actually they are also polynomials. Polynomials. So now in any polynomial, in the terms of the polynomial, we have a constant part and a variable part. Like here, this 4 is the constant part and this x is the variable part. Here, the 5 is the constant part, x square is the variable part, and 9 is the constant part. Here 6 is the constant part, x cube is the variable part, 4 is the constant part, x square is the variable part, 8 is the constant part and x is the variable part. In any expression we have a constant part and a variable part. Okay, it may have only the constant part or it may have only the variable part. Now I will give you an example. Suppose there is a square and length of each side of the square is x. Now all of you know that the perimeter of this square will be 4x. The perimeter of the square will be 4x. Now in this 4x, obviously this is a monomial because it has only one term, and in this expression 4 is the constant part and x is the variable part, because 4 remains the same, the value of 4 remains the same throughout, whereas the variable it may change. Means the length of the side of the square may be 2 cm, 3, 5, 10, 20, any number. So x is the variable, so x keeps on changing, whereas the value of 4 remains same throughout. Clear? Now the perimeter is 4x. Now if you put x is equal to 2 cm, you will get a different perimeter. If you put x is equal to 3 cm, you will get a different perimeter. Is it clear? So I have already explained what monomial, binomial or trinomial are. Now any, say 4x plus 7, any polynomial in which the highest power of the variable is 1. You know here x is the variable and the highest power of x is 1. So in any polynomial, if the highest power of variable is 1, then it is called a linear polynomial. So this is a linear polynomial. This is a linear polynomial. Now in a polynomial, if the highest power of the variable is 2, say 5x square plus 11x minus 9. You can see x is the variable and the highest power of x is 2. So if the highest power of the variable is 2, then it is called a quadratic polynomial. It is called a quadratic polynomial. And in a polynomial, if the highest power of the variable is 3, say 6x cube plus 8x plus 5, the highest power of the variable is 3, then it is called a cubic polynomial. It is called a cubic polynomial. So I hope it is clear to all of you what is linear polynomial or quadratic polynomial or cubic polynomial. Now, what is the degree of a polynomial? Degree of a polynomial. Degree of a polynomial. The highest power of the variable in a polynomial is called the degree of the polynomial. The highest power of the variable is called the degree of the polynomial. In any polynomial, whatever is the highest power of the variable, like here you can see the highest power of the variable is 3. So the degree of this polynomial will be 3. Here the highest power of the variable is 2. So the degree of the polynomial here will be 2. Here the highest power of the variable is 1. So the degree of this polynomial will be 1. Clear? Now, what is a zero polynomial? What is a zero polynomial? A polynomial with all constants equal to 0 is called a zero polynomial. A polynomial with all constants equal to 0 is called a zero polynomial. For example, if we write 0 into x cube plus 0 into x square plus 0 into x plus 0, which is eventually equal to 0 only. So this is called a zero polynomial. A zero polynomial is in which all the constants involved are equal to 0. Okay, clear? Now see, zeros of a polynomial. Zeros of a polynomial. Now what are the zeros of a polynomial? In any polynomial, the values of the variable for which that polynomial becomes 0 are called the zeros of a polynomial. For example, I will tell you, there is a polynomial px is equal to 4x plus 3. There is a polynomial which is equal to 4x plus 3. Now put 4x plus 3 is equal to 0. Then 4x is equal to minus 3. X is equal to minus 3 by 4. That means in the polynomial px, in place of x, if I write minus 3 by 4, then we will get 4 into minus 3 by 4 plus 3. So it is minus 3 plus 3, that is 0. So minus 3 by 4 is the 0 of px. Clear? So that value or those values of the variable such that for that value the polynomial becomes 0 is called the zero or called the zeros of that polynomial. And here is the example. I'll give you one more example. Say there is x square minus 5x plus 6. There is a polynomial px which is equal to x square minus 5x plus 6. Now you do one thing, in place of x you write down 2. In place of x when you write 2, you can see we are getting 0. That means 2 is a 0 of px. 2 is a 0 of px. Clear? Now do one more thing. In place of x, you write down 3 also. So it is 3 square minus 5 into 3 plus 6. That means 9 minus 15 plus 6. Once again you can see we are getting 0. That means 3 is a 0 of TF. Now here in this example you can see there are two zeros, 2 and 3. Here there was only one zero, but in this example there are two zeros. So always remember, in a linear polynomial we will get one zero, in a quadratic polynomial we will get two zeros, in a cubic polynomial we will get three zeros. Is it clear? So the number of zeros, it depends on the degree of the polynomial. Okay. Now suppose there is an expression 4x cube plus 8x square minus 7x plus 5. Definitely it is also a polynomial, and you can see it is a cubic polynomial. Now we are going to divide this cubic polynomial by x plus 2. We are going to divide it by x plus 2. Simple division that you have done in junior classes also. First of all, it is 4x cube and here it is only x, so you multiply it by 4x square. So it is 4x cube plus 8x square. Now sign change. Now minus 7x plus 5. It is 7x here it is minus 7x. So multiplied by minus 7. Minus 7x minus 14. Once again change the sign and you will get 19 here. So you can see 19 is the remainder. Now we can directly find the remainder in this case without dividing it. For that, you are dividing 4x cube plus 8x square minus 7x plus 5 by x plus 2. So you put x plus 2 is equal to 0. Then x will be equal to what? Minus 2. And now in this expression, in that polynomial, every place you put x is equal to minus 2. So 4 into minus 2 cube plus 8 into minus 2 square minus 7 into minus 2 plus 5. Clear? So 4 into minus 2 cube will be minus 8 plus 8 into minus 2 square will be 4 minus into minus plus 14 plus 5. Now it is minus 32. We will continue here, minus 32, then plus 32, and 14 plus 5 is 19. So you can see we are getting 19 as the remainder, and this is called the remainder theorem. The method that we have used here is called the remainder theorem. It is called the remainder theorem. Now remainder theorem says if Px is divided by x minus a, then PA gives the remainder. So we can directly find the remainder by with this method. Put x minus a is equal to 0, then x will be equal to a, and there in place of x you have to put a and you will get the remainder directly. So I hope the part of the polynomial that we did today, it's clear to all of you. So go through this video carefully and then attempt the questions given in the assignment, and your assignments will be collected once the school reopens. Okay, and in the next period we will continue with the remaining part of the polynomial.